Good afternoon, everyone. Respected Padma Shri Parmi Singh Sahab, Professor K.V. Peter Sahab, BDG Sahab, all other dignitaries from KEU who gave me this opportunity to share our thoughts on potato cultivation, and also fellow delegate participants. We'll be sharing our thoughts on recent developments in crop management of important vegetables under polyhouse and rain shelter. Of course, most of the work is concentrated on polyhouse itself, and some of the crop management practices are taken for polyhouse experience to the rain shelter also.
What happened? Some
Yeah,
problem?
slide's not moving.
Slide not moving. Somebody can help. Somebody can guide him. Sangeeta, guide him.
Sir, on the left side, can you find the panel wherein you have an arrow key, sir? On your screen?
Yeah.
You can do that from there, sir. The down arrow?
Okay.
Yes, yes.
Thank you, thank you. So we know all why potato cultivation. Morning, Balraj Singh Sahab also told about many things, and the potato structure he elaborately covered. Just I was thinking from low end to high end. Probably somewhere we have to strike a balance based on the situation. It's not a tailor-made for all the situation of the crop. Starting from a simple floating row covers to control viruses in some of the crops like watermelon and other things, and maybe highly computerized greenhouse operation. Everything exists in India. But when you talk about this economy, internal rate of returns and other things, still there are questions where we have to strike balance properly. Still we are talking about mostly naturally ventilated polyhouse and maybe net houses. That's where we are striking balance in the present context in different scenarios in the country. And naturally ventilated polyhouse, some design issues because management, we cannot think of the controlled condition we say, but still we have to, for the economy purpose, we have to think about design aspects and several other issues. And there's a quite good standards for the design of the polyhouses using tubular structure, which is the quite important, and there are a lot of guidelines developed by the various state departments and funding agencies. And one thing I wanted to highlight here is many times we refer A class, B class, C class, and we are not using those things mostly in the greenhouse construction. They're all now the industry is in terms with about 2 mm thickness of the GI pipes, and most of them, the earlier structure were used with the welding material, and now it is settled to almost connected with the clamps, nuts and bolts, and this is the system that we are seeing now. And the quality is very important. The quality of the material that we are using is very important. The thickness, if we say 2 mm, how to come to contact this one with the terms with the 2 mm thickness. So we have this length and thickness association and width, what is that, the diameter of the pipe. So this will be, this table can be used to come to know about the thickness. And the greenhouse covering material, of course, polyethylene is the most widely used, though we have so many other things for what is that, polycarbonate. This is the most economical things. And in this also, there are several aspects we need to consider while selecting the polyethylene sheet. And we need the light, but we don't need the heat. That's the biggest problem. I think the major challenge what we are seeing the present and also future is the temperature inside the polyhouse, relative humidity inside the polyhouse, the environmental condition inside the polyhouse, with the indispensable way how we can control these things. That is a real issue, one of the researchable issue. And most of the time what we are using is a 5 layers film, and all these 5 layers are ascribed to different properties of the film. 3 layer, 5 layers, and now even the 7 layer films are available, and we are using around 200 micron poly sheets. And this is the different structures. We can see floating row covers and row tunnels, rain shelter. Rain shelter is for a humid tropic, wherever 1500 mm and more, if rainfall is there, definitely the rain shelter is helpful. And not only 1500 mm, even 800 mm rainfall in Bangalore in the Kharif season for tomato crop, you can see the difference of rain shelter. The right side is open field and left side is a rain shelter. We could not control the blight disease, early blight and late blight in our experiments. So a rain shelter gave the answer. So probably now mostly the whatever the protected cultivation, especially in the south or in and around Bangalore or some other place, it is really acting as a protected structure for rain, actually excess rain. And we can say that many times it is though the intended to protect against the insect pests, many times it's not happening because of the reason that I'm going to explain further. These are in shelter in Nepal, Northeast, and other places. This is one structure I wanted to also emphasize, like what Dr. Baljar Singh Saab has told in the morning. The net houses, and there is a several design aspects has come, and this is a flat roof net house with the least steel structure in that. This could be one of the preferred structure to manage the temperature in a hotter climate where the temperature is more than 38 degrees centigrade or so in the summer months. This is the growth in a flat roof net house, even in a condition like Bangalore, what we can see. And this is the mesh nylon net house where you can seclude all the insects so that you can grow some of the crops. Safe vegetable you can produce here using this kind of structure, because leafy vegetables and other vegetables which are eaten freshly, the consumer demand is to get the pesticide residue product, at least though not organic produce. So in such situation, this kind of things will be helpful. And the important thing, what we started 18 years back in the protected cultivation, we are not having the clue that these vegetables can be grown, whether it's a commercial venture. And this is the seedling production. Even now it is very relevant. And the seedling production, almost we have come to halfway, and we are still go further in get of quality seedlings, maybe using V-shaped plugs, maybe using automated seedling production assembly line, or some other issues. And also the mesh size, what we are using, the 40 mesh definitely will not control the whiteflies and thrips. And these two are the vectors which transmit the viral diseases. Of late in the protected cultivation, this viral diseases become very big problem, and we need to produce disease-free, virus-free planting period, at least 35 to 40 days of capsicum or other seedlings. They should not be contracted with the virus diseases. So one of the important issue is having insect proof, really insect proof net house, and so that we can get a quality vegetable seedling from where we can take off our protected cultivation of vegetables, because it is a very costly enterprise, not only to construct a poly house and also to produce. So this is one of the earlier structures way back in 2000 year, not 2000 year, 2020. We can see the net covered sides, and this is a farmer's field. Fantastic net houses people started in Bangalore. Second issue is the media. Earlier the cocoa peat used was with a different process, and now what the microbial stays is not a decomposition, it's a fermentation, and it's using the microorganism culture consortium of the fermented the consortium, fungal consortiums, and also enrichment with the Arca microbial consortium. So 6 set of microorganisms are used to convert the raw cocoa peat into a nursery grade cocoa peat, and in this process there is no washing or adjustment of pH or the adjustment of EC, all those things. The raw cocoa peat is direct, will be used its one, and this is a commercial success technology developed by HR, and this is one of the technology for seedling production. And after the seedling, then coming to crop options, really the biggest challenge is for us in the protected cultivation is the crop option. Now hardly there are 2 crops I think we can name of larger area, that is green or color capsicum, and number 2 is English cucumber. Though we say much about the tomato in the niche areas, it is there. Otherwise, as a bigger commercial area, the tomato crop in India is still less. And other than that, we can have different kinds of chilies, jalapenos, then some exotic vegetables, bottle brinjal. We can try seedless watermelon, melons, snap beans, all those kind of things we can try, but their area is very, very less. We also have the list of exotic vegetables. Their areas are counted in fingers. The major consumption of these are the exotic vegetables we can think of. European cucumber or Parthenopa cucumber, broccoli, zucchini. Of course, zucchini need not be grown inside a polyhouse. There is an issue of pollination also. And lettuces, this is catching up. And some areas under red cabbage. And the exotic vegetables of moderate consumptions are these things, cherry tomatoes and celery. These are the vegetables that we can think of. And some of the culinary herbs, these are export oriented, and it's grown in very, very few polyhouses, but the list is there. We have a very big list of crops, but really we need to explore these things, tie up with the market, give the production practices to the farmers, and a lot of things has to be done. Maybe the new FPO and other regimes, probably it will get some fill up. Otherwise, we are now encountering with only 1 or 2 crops. That's the biggest hindrance for the condition of protected cultivation expansion. Now coming to management of environment, though we say controlled condition, most of the polyhouses are not controlled. It's beyond our control. We are moderating only this one. So we are using the ventilation through nylon nets. The sides are covered with the nylon nets. The tops are covered with the nylon nets. And the issue is if you are decreasing the pore size, the temperature will increase. The present recommendation of 40 mesh nylon net, what we say, they can allow the most deadly small insects like thrips and mites and also whiteflies. So if you increase the mesh or reduce the mesh pore size from 40 to 50 to 60, then there will be a problem of development of heat inside a problem. But a 50 mesh or a 60 mesh, a 50 mesh could be good enough so that it can control the whitefly entry and the thrips entry through net. If you can manage the double door system of entry, and if you are not allowing that, so at least we should go for a 50 mesh. At least for the nursery, we have to go for a 50 mesh so that the virus is not affected in the nursery stage. So this is another design parameter what we can think of, like morning what Dr. Ballar Singh was telling. Increase the area under ventilation from the sides as well as on the top, so that we can have a meaningful air exchange, so that at least whatever the ambient temperature is there outside the air temperature, that much we can maintain. Otherwise, the polyhouse temperature inside will definitely go 3 to 4 degrees more than outside temperature. It may not be suitable for majority of the crops. Now, shading is a double-edged sword. If you put the shade, then again, I think the Kerala condition is the classic example. The rainy season, you have a lot of cloud cover, that itself is 50% sunlight. Then the poly sheet, which is again with the algal growth and other things, then the cut. Then again the shade net, there is no scope for shade net, at least in the Kharif season. So that's why the shade, most of the time we recommend hardly 35% cut shade nets. But sometime in the summer, peak summer, we may require 50% shade net for some of the vegetables. But for vegetables like cucumber and tomato, absolutely shade requirement is very less. And using shade net to control the temperature is really going to be disadvantageous. So one thing we can think of, aluminized strips which reflect the part of the sunlight, so that it will give a shade and also reduce the temperature. And relative humidity is the real issue. And we know that relative humidity of 65% to 70% is quite ideal. And the humid tropics, this is really one of the biggest issue, because the ambient humidity itself is around 85 or 90 or 95 sometime in the rainy season. And there is no practical way of reducing the humidity built inside, and which leads to several problems like disease problem and also the problem of pollination and fruit set. So coming to general crop husbandry, when we started, there was a recommendation of fumigation using the formaldehyde. The recommendation is already there: 4% formaldehyde or 10% formalin, 4 liters per square meter. This is good for sterilizing the soil. But the bad thing is very difficult to apply, and also very difficult. All beneficial microbes that we are thinking of putting, all will be sterilized. So it is not a practical way nowadays. We are not following that one. We are following and we are managing all our greenhouses for the last 10-15 years with all these bioagents like Trichoderma, Pseudomonas, Pasteuromyces, and Pochemia, what our nematologists developed in IHR. We are using this with the neem cake, around 800 kg neem cake per acre, and we are getting very good control of all soil-borne diseases and also nematodes by using this practice for several years. And there is no problem with nematodes in our polyhouses using this kind of neem cake enrichment with the bioagents. So we can think of basal fertilizer application to reduce the cost, and drip irrigation is a rule in a polyhouse. Mulching is a debatable issue in a polyhouse. We can think of mulching, that's an advantage, but if the cost is a factor, and some other issues like snails and other things are there, we can think of avoiding mulch also in a polyhouse. But in a net house, the mulching should be there because it protects the soil from beating rainfall. So mulching, it will help us in a larger extent, but not an absolute necessity. We can think of without mulching also. The spacing and other things, what we are following is 5 beds in a 8-meter bay, and so 80 centimeter bed size and 80 centimeter walking space. This is generally followed for tomato, cucumber and capsicum. And cucumber and capsicum, we follow 2 rows in a bed, planted 45 centimeter between the plants for capsicum and 60 centimeter between the plants for cucumber. And for tomato, it is again 45 centimeter between plants planted single stem. Training and pruning is very important. Why it is important is to get the quality fruit. Quality means in terms of size. So it is just like a family planning. Probably if you allow more branches, your size will come down. We have seen in our several experiments the yield level with the 4 stem or 2 stem, or even for a green capsicum, even in unpruned capsicum also, the yield level remains same, but the fruit size of the same cultivar range from 100 grams to 200 grams. So training and pruning is ascribed for a fruit size. For the high-end market and for the export market, sometimes we need a bigger size fruit, at least 50 grams of capsicum. That is very important. And tomato is another problem is the training and pruning. The tomato tend to grow up to 30 feet in a polyhouse, though the crop which is growing around 10 feet, indeterminate hybrids, will grow 30 to 35 feet, and we need to regularly lower it. It involves a lot of costing on that. And in this effect, we have also tried the determinate hybrids, like the whatever the popular hybrids that we are growing outside. For example, the indeterminate hybrids, most of them are imported one, and also there may be few varieties from Pantnagar, but this involves a lot of labor. And for a local market, whatever the preferred local fruit type we can think of, a variety which is growing only 5 feet in open field is conveniently growing up to a height of 10 to 12 feet in a span of 6 to 7 months. So there is absolutely no problem of using determinate hybrids also in polyhouses. We could get 150 tons per hectare or 60 tons per acre of determinate hybrids in the span of 6 to 7 months using our hybrids, older hybrid like Arkananya, and also the popular hybrids of private hybrid like Abhinava, NS501. We all tried this one and we could get, but only thing is we should not prune it. We have to allow 6 to 8 branches, and individual branches we have to try. So this is the system for tomato. In areas like Kerala or in the Northeast, where the transportation of tomato is an issue, and they are bound to get more product. And tomato is fairly one of the easiest crop compared to capsicum in terms of plant protection. So when you are growing in a polyhouse, there is no question of borers. Only you may have some fungal disease problem and mites problem. So largely you can produce a pesticide-free tomato using polyhouse conditions. So one of the possibility of more than a capsicum, the tomato is a possibility for a humid tropics like Kerala, that to produce a safe produce. And another issue with the polyhouse cultivation or the production technology is irrigation and fertigation. So inline drip laterals or drip irrigation is a rule in a polyhouse because we can get the equitable distribution. And also very important thing is we should not apply over irrigation, because most of the problem that is being caused is due to the over irrigation. We do not know how much to apply, and so this is generally how much to apply means we have seen almost in the pan evaporation system, maybe 50% is more than enough. And in a Bangalore condition, we have seen in some of the crops, even 30% of the pan evaporation is quite good enough when you are using a polyhouse, and when you are using a mulching system, even up to 30% is good enough, saving 70% of water in a polyhouse system. So we should not give more water. If you give more water, what will happen is whatever the fertilizer that we are applying, that will be draining out of the root zone. Coming to automation of irrigation, the simple automation, we have the system called aerometer, or this is a tensiometer that can be connected to the controlling system like dosatron, or not dosatron, the controlling system which is coming now with the auto fertigation unit. So we can automate the irrigation practically, and we can say that whenever the soil atmospheric tension comes to 0.3 bar, the automation of irrigation is triggered. So this kind of automation is possible with kind of tensiometer, and some other systems also coming. And when the irrigation is through drip irrigation, the absolute choice is fertigation. Fertigation is nothing but a multiple split application. Earlier, when we grow vegetables, hardly we used to apply twice or thrice in the entire growing period of 4 months or 5 months. But here what we will do is at least once in a 3 days or once in a week, or in some cases maybe daily, as in the case of grow bag culture, we are applying the same amount of fertilizer through multiple application. So we are getting the maximum use efficiency of fertilizer and also increasing the yield. The important issue here is the completely water soluble fertilizer, which is 3 to 4 times more costlier, and we have several such systems. We have several fertilizers, solid fertilizers. Earlier we used to think of liquid fertilizers, but because of transportation other problem, we will be using mostly solid fertilizer. And these are the future when we are applying more fertilizers. See, our recommendations are minimum 125 kg, 100 kg, 125 kg per hectare. But if you want to increase the yield in certain cases and do more of fertilizer, then we need to have a fertilizer which is giving no salt buildup. Our regular fertilizer will be having some salt content. If you put more fertilizer, then that also will be an issue. And there are several kind of fertilizer injects. Venture is most popular one. And there will be a different fertilizer injector. This is a research Anderson multiple injector, and we have now good fertilizer injector from Priva or from Netafim or from Gain Irrigation. So there will be getting on this. There are several other inexpensive models to inject the fertilizer precisely based on the volume. And this is the computerized control system. Still, it's an infantile stage because of the cost factor. Probably all this computerized control system may cost you very, very dearly for us. For example, this kind of system to establish may cost you around 10 to 12,000 per square meter, whereas now we are talking about 800 to 1,000 rupees per square meter to build a polyhouse. So 10 times costlier, and are we getting 10 times higher yield, return and other things? And probably we are not able to show this one so far, and that's why it is still as an experimental stage, or it is still in a demonstration stage. We have several center of excellence in the country. They're all trying to show the beneficial aspect of these things. Now I said to go for a fertigation, the cost of fertilizer, the water soluble fertilizer, 100% water soluble fertilizer is an issue. Then how to economize the cost of fertilizer? We can think of apply a pre-plant fertilizer containing recommended amounts of micronutrients, calcium, magnesium, sulfur, phosphorus, and even up to 20% of recommended NNK, and remaining NNK scheduled injected during the growing season. So by this way, we can compromise some kind of yield, but we can save at least around 1 lakh rupees per hectare on the cost of fertilizers. So this balance we need to see. This depends on the value of the crop, what we are growing. Whatever we started capsicum as a high value crop, this season there is a very high value, but otherwise sometimes the capsicum also may not be fitting as a high value crop. And we need to grow high volume and low value crop. So that's why we need to think of this kind of economizing we have cost of fertilizer. There are several recommendations. This is one of our earliest recommendation for tomato. Once in 3 days, 4 kg of 19-all, 1.5 kg of potassium nitrate and calcium nitrate blanket recommendation from 30 days or 35 days after planting. And the capsicum also same thing, 200. This is our the first experiments on capsicum. Of course, now we have changed it. This is NPK will not be equal. There only the phosphorus will be sufficient, 65 to 75% of NK. The thumb rule is 1:1 or 1:1.25 N and K ratios, and P to N ratio is 0.65 to 0.75. That much is enough. We have seen in earlier trials in all the 3 crops. That much is good. This is experiment with the 200. And tomato, this is the experiment with the 250. And English cucumber, we have seen the fertilizer recommendation quite optimum with the 125 kg NPK per hectare. We have gone up to 250 kg NPK per hectare, but there is no response for English cucumber in a greenhouse crop because there is no leaching. There will be a fertilizer buildup, so there will not be rainfall. Muskmelon was successful with this fertilizer rate, and whole beans is one crop which you can think of growing in between the crops, but it's not a very, very profitable crop. But the crop could be a profitable crop in season like rainy season where the outside crop is this one. And for micronutrient management, we largely depend on the foliar nutrition. Once in 15 days, we used to spray vegetable special or the other micronutrient mixtures that is available with the commercially. And this is for the fertilizer recommendation. Of course, we have not standardized this one. This is a popular recommendation I have drawn from elsewhere. Actually, this is for the artificial media. This is from the abroad. Actually, this we can think of to start with. And for the capsicum, this is the fertilizer recommendation. Probably the I will not be discussing this one. The organizer can share, whoever require this one. I have given the copy to the organizers. They can, on request, they can share these kind of things. Probably whoever want to try the basics of soilless cultivation, these are the schedules available. We can think of this one, what is the tanks liter, what is the kgs that is we need to put, everything is there. And this is the dream model. There are one or two model available maybe in the country. See, this is a total automated recyclable water and nutrient system. See, for example, greenhouse capsicum production, we have sensors that monitor the environment, weather, humidity, and other things will be there on the top of the greenhouse, also on the soil. And from there, it will come to a drainage system. So drainage, there will be a storage tank for return, purified and mixed and purified sterilized water. UV sterilization and other things will be there. In the silos, then reverse osmosis and UV sterilization. So then the mixing and monitoring, if the nutrients are depleted, it will be mixed here in the mixing plant. And again, this water is recycled. So nowadays, whatever the cocoa peat cultivation or the soilless cultivation, what we are talking about, lot of the used fertilizer solution are drained out. That's a problem for the environment also. That will be costly. So this is a closer system, a new generation greenhouse operation we can think of. And here a lot of whatever the morning discussed, that is artificial intelligence, robotics, and all those kind of things will come to use. And this is the future that we can think of for a greenhouse, and we can have a model. Rain harvesting is very important, may not be very suitable for Kerala-like situation, but for an arid situation where 1000 mm less rainfall. And in Bangalore situation, we have seen almost 10 months of crop can be taken from the rainwater harvested alone, using the low volume drip irrigation discharge 2 LPH, using mulching system, and harvesting at least 15 lakh liters from 1 acre. 1 acre polyhouse means you should have a storage capacity of 15 lakh liters. Then we can think of, we can do a rain-fed polyhouse farming in an area of a arid region, not very arid region, but semi-arid region, like a situation like Bangalore. So this is the thing, and elaborately Dr. Saab in the morning discussed the pollination, real issue in the polyhouse because of the cross circulation of air and also because of other things. As Dr. was telling, we are trying to import bumblebees, and we are doing this thing for the last 10 years. Of course, it's not going to happen. There is a lot of efforts in the country to use the native pollination. I think we will be getting some in our institute also on muskmelon with the little bee. We could get some good success, and similarly some other things. And of course, the production constraint, the major production constraint we can think of is the nematode. Nematode is the biggest problem, and whatever I said earlier, the bioagents is also a solution for a nematode. We have seen that one, and the thrips is a real big problem. Every polyhouse, at least in the southern tropic, they are affected with the thrips and mites. And one of the reason is whatever the insect-proof net house is, we are telling, it is not giving an assistance. Once an insect goes inside, that will release the condition, whatever there inside the polyhouse. And it has become unmanageable. We have to think of several options, integrated systems. And this is the nematode problem. For nematode problem, this is one propagation aspect. We have the marigold, and we need to target the soft insecticide like neem soap, conventional products, insect growth regulators, soaps and oils, microbial pesticides. And this is another dream thing which is not happened so far. Brahma Singh Saab also knows, predator and parasites not in a large scale produced in the country. And there were two companies which wanted to import from Israel or Holland, and that also did not be demonstrated properly in places. And I think leaving aside this predator and parasite, we have to think about the microbial pesticide, other natural products, and think of reducing the pesticide usage to increase the export potential and also the safe consumption for the country personnel. So this is very challenging aspect. Another issue is the powdery mildew in a polyhouse. Maybe the resistant varieties where the people are trying in several places, maybe an answer for capsicum. And bacterial wilt, no, this is the Phytophthora wilt is the biggest problem in capsicum, even in an area like 800 mm of rainfall. And this is the net house crop. That's the biggest issue. Net house, one of the problems the net house is the Phytophthora wilt, and of course the morning Naran Kuti Saab has told about the grafting. Definitely, it will come to help in this kind of situation. Downy mildew, of course, can be controlled. There are several varieties, especially in English cucumber. Many varieties what we are getting, which are imported, are downy mildew resistant. There's all those things. And coming to some summary part of it, we are talking several things. Probably, whenever we talk, we start from vertical farming and NFT. But I beg to disagree. We need to do a lot of things, fine tune and other things. This definitely we need it for the future, but at least we have not solved several issues. The first issue is the temperature. Along with the engineers and other people, we need to see how affordably we can cool the greenhouses. At least some meaningful production will come. And minimal automation, curtain movement, irrigation, fertigation. This we need to. I'm talking about the grower level and talking about the return, talking about the investment for the return. So in this perspective, this summary, that's why I put these two issues of NFT and vertical farming the last in the list of these things. Rainwater harvesting is happening. Crop diversity, biggest problem is now we need to have more crops. You see, tomato is also a good crop. Tomato, potato, onion. You know the onion problem, especially in the summer rainy season. At least tomato crop can be a good crop. If a grower can get at least 20 rupees a kg in his farm gate, tomato is one of the biggest crop, and you can get a quality tomato. There will not be handling and post-harvest losses when you grow tomato inside a poly house. So that way, but the issue of the pollination, if the pollination is solved, then we have several crops from the cucumber beets which can be grown, bitter gourd, bottle gourd, and so many other things we can think of growing in a poly house. And rootstock breeding. For a breeders, I think the ultimate, the first objective should be the rootstock breeding. I don't think the breeding for the crops is very, very challenging. Probably the quality, disease resistance, and it is going to take a lot of years, can be given a low key, but rootstock breeding, immediate result, and will be having immediate usage. And soft pesticide, INM, and biopesticide, these are the need of the hour, we need to do it. Then media culture is possible, not the water culture, but media culture is definitely possible. Several farmers have become successful. Several farmers have seen the money out of media culture. With little fine tuning and research and extension, media culture can come immediately. Then comes the breeding greenhouse variety for disease resistance, definitely, and the quality. Then fully automated greenhouse, probably fully automated greenhouse also may come in the bottom of the list. So this one, whatever I wanted to share, thank very much for the officials and authorities of the Kerala Agriculture University for giving me this opportunity. And also thanks to the chairman, Brahma Singh sir, and thank you for everyone for the patience hearing. Thank you very much.
Dr. Heber, sir.
Yes, sir.
With the permission of the chairman, may I ask a question? Dr. Brahma Singh, sir, can I ask the question?
Sir is muted, I think.
Yeah.
Sir, please unmute, sir. Dr. Brahma Singh, sir, please, can you unmute?
Hello. I have to thank Dr. Heber first for giving the excellent presentation and covering almost all the aspects with all problems along with solution hurriedly. You are welcome to ask the question one by one.
Okay.
Thank you, sir.
Dr. Heber, in
Yes.
Kerala, people are now going after rain shelter. It's
Yes.
not poly house, but rain shelter. And in your opinion, what is the prospects of this rain shelter in humid tropics?
Yeah, I think the prospect is better than the polyhouse, sir, in the humid tropic, because we cannot think of, in a rainy season at least, we cannot think of any vegetable production, of course, apart from the traditional vegetable what is grown in a rainy season in a situation like Kerala. But other crops, if you can think of, it is not possible to grow in a rainy season because of rainfall. So rain shelter could be the better option, sir, compared to polyhouse. Polyhouse, again, the humidity problem is there. You know the situation there, the humidity is always more than 85%, 90%. So at least rain shelter will prevent the rain or will give the benefit of rainfall prevention, and we can think of popularizing more of rain shelters.
Rain shelter along with the net house all around to check the entry of at least some insects.
Yes, sir.
That is a better option, what I feel, and that's what I think Dr. Balraj also advocated.
Yeah, probably they can have a trial, sir. One thing is problem is the insects are definitely are not screened by 40 mesh nets, sir. But
No,
when you
it's
put
okay, but at least the some which are nuisance.
yeah, borer we can think of, sir. We can think of a borer prevention by using a 20 mesh, bigger hole size. And the borer is a bigger nuisance. And some of the, for example, cowpea, if you are thinking that the tea mosquito bug, all those things can be screened with a bigger mesh. But whatever the national policy that we are making 40 mesh net, that you need to see for the local situation, which kind of net is better for rain shelter in the humid tropics, sir.
That's right. At least we have to tell to the farmers what is to be used and what is not to be used. And I'm wondering whether in a rain shelter you can put a solar fan to take care of that your humidity part.
Yes.
Okay. Then in that case, Haber sir,
Yes,
what
sir.
should be the dimension, ideal dimension of the rain shelter?
So rain shelter need not, for example, I know in Kerala, the design is there even up to 8.5 meter high central height polyhouse design is also there. Because for various reasons of the condition of the humid tropics, the greenhouse design even gone up to that height. So it becomes a very big problem in terms of cost, in terms of the maintenance of the structure, in terms of wind damage, all those things kind of things. So rain shelter need not have that much height, sir, actually. Whatever the rain shelter we had in Bangalore is hardly 10 feet height, not even 10 feet, 8 feet height. We could get wonderful crop under rain shelter. But there it may be little more than that. It has to be just, I know the example of China, sir, Dr. Brahma Singh sir may be knowing. They are having the rain shelter or they are having ground cover, at least to, I missed that slide here. In the rainy season or whenever the rain is there, because in Kerala we cannot think of growing vegetables in a 1 acre size, 2 acre size, bigger this one. It's all homestead kind of things. Maybe 100 square meter, 400 square meter is good enough. So such model we can think of whenever
easy to manage.
Sir?
Smaller size, easy to manage.
Easy to manage, sir. You can think of the changing the sheet based on your climatic requirement.
Oh yes, it has to be according to the climate.
He can put a poly sheet in the rainy season. He can put a shade net in the very summer, hot summer. We can think of when the insect population is more. We can put all those kind of things. We can keep reserve, change it. If a 100 square meter ground to ground kind of rain shelter, we can think of, sir.
Oh yes, you are right. Somewhere you mentioned the retractable greenhouses or polyhouses. That is also a answer.
Yes, sir.
Okay. Okay, sir. Then the other question is regarding the crops. Can you suggest suitable variety for each crop?
Variety, damn difficult.
Variety or hybrids?
Sir,
Very difficult question. Anyway, you answer.
I had the list. I deliberately missed that list. I can share you before the seminar ends. Because there is a next speaker is on variety and hybrids only. That's why I did not touch. Otherwise, all the popular hybrids and varieties being grown in the country. Because we have only few National Institute released varieties. Most of the varieties are from the imported from Israel or Holland. And there are several companies and it is in the public domain. We can list it, sir. There is no problem.
Okay, because maybe the participants will be interested to know all those things. Because
Yeah,
in the chat box, I didn't find many questions. That's why on behalf of them, I am asking.
It's good.
Yeah, because for tomato in the humid tropics, because Dr. Narayanankutti was highlighting Lakshmi for this track. So like that, in your experience, which hybrid is better in this track?
Sir, tomato, whatever the popular to the region, because somebody may be having round, somebody may be requiring flat, somebody may be requiring acidic condition, somebody may be requiring table. So that changes. So whatever is the popular in that region, they can think of growing inside the rain shelter. They need not get the greenhouse specific varieties which are indeterminate and it will be difficult for the small farmers to follow because it's okay for high-tech commercial kind of farming in a bigger way. Otherwise, they can try. We have tried all the local popular hybrids in a greenhouse. of 3-meter side height and 4.5-meter central height, the low height polyhouses, and we are successful getting 60 tons per acre of tomato, the determinate common hybrids. So that can be, people can start with that, but only thing is they have to give sufficient spacing. Our regular textbook spacing will going to fail this tomato crop. They should space at least row to row 1.5 meter, plant to plant at least 3 feet to 1 meter. So such things, and 5 to 6 branches will give more of ventilation, will give the better fruit set, and will control the vegetative growth. In the tomato and cucumber, biggest problem is the vegetative growth. You will not get the yield. We will apply the recommended fertilizer of 250 to 250 NPK. We give excess water. We will not prune anything. And added to that, there will be shade net also will be there. So your tomato crop will become a nice jungle, and there will not be any yield. This is the problem in many times we have seen it. So that should be avoided.
No, nobody wants jungle. Everybody wants crop. That's right.
Thank you very much, sir. Okay, sir. My last question.
So anyway, it is all regional based, depending upon the climatic condition and consumer.
Yeah.
You have to modify everything.
My last question is on nematodes.
Yes, sir.
Root nematodes, I think there is no solution so far. Habbar Sahab will answer his own preparation from there. Their own preparation is there. But
Yes,
at least, as far as I know, solarization, application of neem cake, and using your marigold. Beyond that, I don't think there is any answer to root knot nematode. You kindly follow the crop rotation. After 3 years, if you are intensively growing vegetable, you have to change it. Or if you can afford to change the soil itself in a limited area, say half an acre or quarter acre, that also will work. Or if you can afford the solarization is effective.
Yes, sir. As already discussed, our bioagents are working fine. What I feel is because we are continuously growing only these crops, tomato, cucumber, and capsicum continuously in these polyhouses. Now the 6th year we are growing, and after every crop we are monitoring the nematode load, both its score as well as the soil egg condition. We are monitoring it, and as I said, 800 kg of neem cake.
Just a minute, I'm stopping you, Habbar. Here,
Yes,
this nematode is not a single entity. If you have got Miladogyn incognita, okay, it holds good.
Yes, sir.
Suppose he has got a different species, that may not. So it has to be regional basis only.
Yes, sir.
General thing you can tell it.
Okay, sir.
Otherwise, it's not that easy to control these.
Yeah, it is not easy, sir. Yeah, we are seeing a lot of the farmers are
Real
facing
crop. Only thing I think grafting is working.
Yeah.
So far. I don't know in future what happens.
Yes.
Okay, sir. Thank you, sir. Thank you, Dr. Habbar.
Hello, sir. There is one question.
Yes, sir.
Can I ask?
Oh yes, why not?
Yeah. Sir, they have asked what is the procedure to remove the algal problem on the cladding material. Is there any safe method to remove the algal?
Algal in the polyhouse is the biggest problem, especially in the humid tropics. Only the possible solution is a bleaching powder and abrasion. We need to mechanically clean it.
Habbar, you simply say cleaning, whatever they use it. Simply cleaning, that's all.
Yes, yes.
It has to be cleaned.
But a very difficult situation.
Very damn difficult.
Yeah.
You have to maintain, you have to be cautious, you have to minimize it.
Small
Totally you can't.
Sir, is there any chemical that can be recommended to kill the algae?
Habbar Sahab, you telling chemical for algal.
As I know, it is only the bleaching powder.
That's all.
Sir, there's another question. What is the scope of the growing unconventional crops like cucurbits and cowpea in polyhouse conditions?
We are thinking of talking about the scope of these things, that exotic vegetable, what we call for the last 15 years, but not taken up in a big way, including even a cherry tomato. We can see how many acres are around a very highly polyhouse area like Bangalore and other places also, the growers are quite numbered. We have maybe 1,500, maybe 500, 600 capsicum growers, but hardly we can find one or two cherry tomato growers. So it is a very limited market. That's why the scope is it is developing only.
The market will develop. Let us hope. That's all.
Yeah.
So another question that has been raised is how to take care
How
of
many do you have got in the store? The questions?
So this is the last one, sir. The last question.
Okay. Okay.
Yeah. How to take care of the problem of heavy wind problem in the polyhouse conditions?
Wind problem. Structural engineer. Okay. Haber Saab, yes.
Yeah, it is only structure stability, good construction from the, because now there are a lot of polyhouse fabricators who can bend the metal, they are all become a polyhouse fabricator. So that should not be a thing. And it should be a time tested, the fabricator, they have to use it and put the, and of course, we design the polyhouse for 128 kilometer per hour, but many times the polyhouse sheet going is beyond 40, 50 kilometer also sheet is going up. But many times you have seen the, even the structural malformation due to poor execution. It is a very difficult situation, but quality construction is the key for that. Because fastening has to be good. The grippers, the fasteners, all those things can take care for certain extent.
And to be very sure, if you can get the insurance, that is the good solution.
Yes, sir.
Because you don't know what intensity of storm you can get. You can't predict.
Thank you, sir. And
Thank you.
no more questions, sir.
No more question. Okay, good. So, kindly introduce the next speaker, Hadra sir.
Sure. So the next talk in this session is on future vegetables and new generation hybrids. The speaker is Dr. Pranab Kumar Hazra. He is the Dean of Postgraduate Studies and Professor, Department of Vegetable Science, Faculty of Horticulture, Vidhan Chandra Krishi Vishwavidyalaya. He has a long career of 35 years and experience in teaching as well as research in vegetable science. He has contributed to the breeding of 10 superior varieties and hybrids in different vegetable crops. He was a visiting scientist to the Institute of Genetics, Bulgarian Academy of Science, Bulgaria, and Department of Crop Science, Agriculture University of Athens, Greece. He is the recipient of FAO Fellowship Award, Erasmus Mundus Scholarship of European Commission, and Dr. Kirti Singh Gold Medal of Indian Academy of Horticultural Science. He is the Fellow of the Indian Academy of Horticultural Science and Indian Society of Vegetable Science, and a member of the National Academy of Sciences, India. We welcome you, sir, for the presentation.
Dr. Hadra sir, you're welcome.
Thank you very much, sir. Am I audible, please?
Yes. Yes, you are audible.
Okay. Actually, there is problem in my laptop, so I am talking from the phone, and the organizer will share my slide as they told.
Okay, organizers, kindly help Dr. Hadra.
Is it visible? It is visible.
Yeah. Can you see, Dr. Hadra, your slide?
Yes, it is.
Okay. Good.
Okay, respected chairman, sir. Very nice to see you. My other delegates, my esteemed colleagues from different universities, my dear students. It is really a matter of privilege for me for having received the invitation to talk on this national level webinar. Can you hear me, sir?
Oh yes.
Yeah,
you are audible. You are audible.
Yes, Dr. Hazra, proceed, please.
Please.
Yes, proceed.
Okay. The topic, future vegetables and new generation hybrids. The two different aspects have been dovetailed together. So I will present in the two aspects separately, and later on I shall try to converge on it. May I have the next slide? Next slide. Okay. The concern. No. The previous one, please.
Previous one. This one.
Yes. The future vegetables or future crop we are talking about with a concern in our mind. The concern is the hunger, malnutrition, and hidden hunger. And the recent Global Hunger Index 2020 has presented a very alarming picture for our country, and moreover, particularly for the growing children. And according to the index, about 17.3% of the children below 5 years have been wasted due to acute malnutrition. And the hunger, we have been talking a lot about hunger and hidden hunger, and the two things are not exactly the same. The hunger is basically the protein energy malnutrition, and the hidden hunger, where there is no symptom, is basically due to the deficiency of micronutrients, vitamins and minerals. May I have the next one? The gap, but also it the two sides of the same coin. You see the person touching about one and the
Some problem. Dr. Sahab sound is not there.
side of the coin.
Hello.
But if you see the other side of the coin, it is
Oh,
hello. You see
some
the other
problem
side
with
of the coin.
your audio.
Is it problematic to hear me, sir?
Yeah, some problem with the audio. Breaking, your voice is breaking. Oh, okay, you continue. Continue, let us see.
Okay. And in the other side of the, you will see 1.1 billion, these are overweight due to excess consumption of particularly carbohydrate and protein. And in cases, you will see, may I have the next one? Yes. See, no. Previous one, please. Previous one. The food pyramid, the vegetables are at the base, and it is recommended that at least 30 to 60% of the calorie must come from vegetables and then to fruits. Next one. No, I'm entering to my topic. Very limited species that supply us calorie and protein. Food is really based on the plant. And if you see how many plants are giving us food.
You are audible, sir. Continue.
Okay. We have seen that around 350,000 plant species have been classified so far. However, only 10% have been evaluated for their agricultural and medicinal potential, and hardly 150 plant species can be told as a major crop, and of which only 30 plant species give about 95% energy and protein. So we have started in a very big arena and landed in a very small area, 30 plant species. Now let us see what is the scenario of vegetables. Next, please. Yes. Recently, FAO along with Biodiversity International in a collaborative manner, they have determined and they have enumerated that about more than 1,000 plant species in the world are taken, but hardly 80 species we know their names. Rest of the species, these are used here and there, but we have forgotten. And these are basically most of them are underutilized and unutilized vegetable. They have the potential. So again, come down, you will see from the commercial point of view, commercial means from the market point of view, from the breeding point of view, genetic improvement point of view, we are concerned about hardly 25 vegetables. So we have started talking about 1,000 vegetable species, landed again to hardly 25, which is commercially important now. Next, please. Next, vegetable crops. This is the topic. These are the underutilized traditional vegetable crops and the future vegetable crops. Lot of international level, particularly in the level of FAO, the Biodiversity International, and lot of projections have been given, and it has been documented in literatures. I have given that as an essential source of vitamins and micronutrients, the traditional vegetable holds a tremendous potential. At times, the traditional and indigenous vegetables are more nutritious than the global vegetable that we say. Vegetable like cabbage, like tomato, like peas, these are the global one. Not only that, many underutilized and traditional vegetables are adapted to a very specific environmental condition, sometimes the soil condition, and it needs proper attention. I'll please. Next, please. Next one. Yeah. Very recently again, sustainable diet and biodiversity has been linked by the by FAO, because now for the last 20 years we have been talking about healthy diets, balanced diets, but not sustainable. Unless it is linked with the biodiversity, this cannot be sustainable. Again, the role of the underutilized vegetable, less utilized vegetable, that is very imminent if you want to really sustain the nutrition of the huge population like Indian population. Next, please. Skip on, skip this. Next, please. Next, please. One. May I have the next?
Farmers variety.
Is it the yes? Most of the, even I think all the cases, the underutilized cultivars of the underutilized crop are basically the farmers varieties. We have been talking and we have seen that in many cases, if you take the example of India, farmers varieties are really and the economic stability. In the era of hybrid that will come later on, hardly 35% of the potential have been tapped, and we have seen that 80% of the indigenous tropical and sometimes tropicalized vegetables in India are grown with the farmers varieties. If we broaden the horizon with incorporated crops which are underutilized crops, sustainable nutrition also. The next one. Next one. Vegetable crops, citing the references from the work done by students. And these are, first is teasel gourd. Momordica subangulata, and this is very adapted to the humid tropics and humid subtropics, and very highly nutritious also. Span of vegetation is about 7 months, highly priced also, but it has not elsewhere in West Bengal, parts of Tripura and parts of Bihar also widely. Has not given much attention, but it needs to be taken attention, particularly for its nutritional potential. Next, please. Next, please. Variability our morphology of the female clone. There are variability, and just I'm showing here because I will show another dioecious crop. This naturally pollen bees because of the flower structure. Next is lot of variation is there in the shape, size, spark, and color also. And conspicuous thing in the right hand side thing is that there is difference in the nutritional load in the pericarp and the mesocarp. I will show you. So for this reason, you see this. Next, please. Next, please. Yes. If you see the nutrients, it is quite nutritious. So I want to focus on that. Ascorbic acid containing the pericarp is 190 milligram. Vis-a-vis in the mesocarp is 20.7 milligram. The nutrient, the nutritional trait in the pericarp and the mesocarp. The thing is that we are propagating the idea to the farmer level also, to the village women. Don't scrap the pericarp while cooking it, because it is loaded with the nutrients in case of the cheese board. Next, please. Next, please. Pointed gourd. Now, pointed gourd, it is a major vegetable crops in West Bengal, some part of Bihar also, and some part of UP. But again, this has remained underutilized in other parts also. It is again very adaptive to the tropical humid and subtropical humid condition. Again, it is a dioecious crop. It has got some other problem. Next, please. I'm showing that, but next, please. Next, yes. You see the flower structure vis-a-vis the flower structure of teasel gourd. This is not cross-pollinated by honeybees. This is cross-pollinated by a beetle, small beetle. Because flower is not an open type, it is a long slender pipe-like. So the beetles or any insect must have fall inside to take the pollen, and it is pollinated. And we have standardized the hand pollination technique in pointed gourd. And this is the how it is done, and it is now commercially done in almost all the villages in West Bengal, the part of Bihar that has been sprayed. And one male flower, the pollens of one male flower is sufficient to pollinate at least 8 female flowers to get a good set like this. Next, please. Yes. The promising clonal selection we have also put in the AICRP system. Next, please. Next, please. Yes, these are high potential crop. These leafy vegetables. No, one. Yeah, I have shown it only 8 one. Because of this, the 6 has a very high potential to grow in the marshy land, like Ipomia, like Hydrophogia, like Centella, adapted to a difficult growing condition. That is a marshy growing condition that grows abundantly. And next, please, next slide. Next slide. We have estimated the only two nutrients, the beta carotene and the ascorbic acid, of 24 leafy vegetables that are commonly grown in West Bengal. There are many, but and if you see that the level of carotene and ascorbic acid is quite appreciably high in many crops. Next, please. These are very popular in Assam and West Bengal and Tripura in particular. The jute leaf. We have initiated the work with Central Institute of Jute and Allied Fiber to promote the jute as a leafy vegetable. And if you see the beta carotene iron content, it is stupendous. It is about 7.83 milligram of iron is present in the Corcoras oletorius, which is basically leafy vegetable. Even in Bangladesh also, this leafy vegetable, that is the jute as a leafy vegetable, is a very unique item, but it has not been popularized in other parts. So that is still, as a leafy vegetable, it is still very underutilized, and that warrants attention. Next, please. Next. Okay. Yeah. Something about the crop which is very adaptable to the tropical humid area. Now another crop we are working here, that is snap melon. Snap melon is very adaptive to the drier track, and basically the collections are from the dry, including the Bihar and Jharkhand, and wide variability is there in shape, size, and so it is. Snap melon is not a very high nutritionally rich crop, not at all. Next, please. But wide variation is there in different nutrient content, so that it can help in selection of a better type. It can help in selection of a better type. Next, please. We have been working on wild Solanum species, particularly the Solanum ethiopicum, Solanum anjubi, Solanum macrocarpon. This has got some potential to be a vegetable crops, but particularly Solanum ethiopicum vargilo, but the genotype with less bitterness. Vargilo is comparatively less bitter than Solanum macrocarpon and Solanum anjubi, but some less bitter genotype in the Solanum ethiopicum may serve the purpose, but potential to be a alternative or underutilized crop in the vegetable basket. Next, please. Last one, the underutilized crop is baby potato. This baby potato is a crop of the northern part of West Bengal and northeastern part. This potato is thought with the from the potato that has been introduced earlier, very earlier, say about more than 200 years back, and with the military persons also, or missionary person also, and they are very adaptive to that part. And just next, please. Next. Okay, that paper we presented in the global potato conclave that was held in Gujarat. And if you see that the nutrient profile of baby potato, this is very well comparable to the normal ware potato. If you in the bottom, the average of 3 varieties of potato, if you take the dry matter, the TS starch content, so it is well comparable to that of the potato, normal wild potato. So this is a very region specific potato, so we can say. And we are also working with the CPRI also. We have also done the chromosomal profile also in that baby potato with a broader aspect of the work. So that can be used as a alternative crop, that can be used as a underutilized crop, but it has got a huge potential. Next, please. Okay, the second part of my topic, new generation hybrids. So we have been talking about biodiversity, importance of diversity, and now we are landing to a arena where we will talk about the monopoly. We will talk about the monoculture. So anyway, there is a two different aspect, but later on that may be converged. Next, please. Next, please. Heterosis. We have been talking for more than 100 years. Now, still today, it is the mechanism of heterosis. It is largely undefined, though we know all the gene action, that is additivity, dominance, overdominance, and epistasis, these could be observed at the molecular level itself. How heterosis is manifested, that still it is undefined. But before that, the heterosis phenomenon or the modern heterosis concept that has come from 4 different thoughts. One is the progeny testing at the time of Wilmorin, then double cross from the era of Jones. Then the Schall has made a monumental work on the composition of the field of maize. A homozygosity, heterozygosity concept came, and later on the pure line theory, or thinking of the heterozygosity, and later on we have found that some of the hybrids excel in the characters, even it can excel the beta parent and even excel much higher. It gives a different manifestation also. Next, please. Okay, now just to have a glance, because the heterosis or hybrid vigor, this has transformed to hybrid industry. In my crop, that is hybrid vegetable industry. So it's a huge $1 million industry, but it has came from a very simple thing, development of the hybrid maize. That is a milestone I have also told in late 1920 to 1930. But before that, heterosis was identified in cucumber in 1916. And the first, immediately after the hybrid maize came in the picture, the hybrid brinjal came in the market in Japan in 1931. But again, my topic is somewhat different. The seed production of the hybrid maize is comparatively simple because it has got the separate and male and female flowers. Until date, the hand emasculation and hand pollination is commercially done in many vegetable crops, particularly tomato, brinjal, sweet pepper, okra, even bits also, particularly in India and China. India is the second largest producer of hand pollinated vegetable hybrid seeds, particularly because there are the abundant seeds that produce per pollination. Similarly, the monoecious, gynoecious, endomonoecious sex form is also used for the production of the hybrid seeds in cucurbits, mainly by hand pollination or sometimes as a bee pollination technology. But there are many crops where this technology is not efficient to produce the hybrid seed economically. And here is that first utilization of the self-incompatible system that came again in vegetable crop, that is cabbage. First utilization of the cytoplasmic genic melstrel line, that is onion. First identification of the gynoecious line again in cucumber. First identification of the cytoplasm, that is in radish. First ethylene induced femaleness in cucurbits, that is in cucurbita pepo in 1969. And first identification of the cytoplasmic genic melstrelity in carrot, mold of 1996. Physiology has contributed immensely development of the vegetable industry in the world, and also something in India. Next, please. Okay. Now, why the hybrid breeding is still very highly relevant in genetic improvement? First of all, and the first and most unique way of translating the biological science to industry and ensuring the monopoly. Unless and until the monopoly, naturally industry will not stand. And that is the reason the hybrid stands, because established. Incredible value of the hybrid for enhancing yield is a tremendously, it can enhance the yield. And some of the uniformity in expression. Uniformity expression is not a new thing in the self-pollinated crop. It's a rule. But in the cross-pollinated crop, uniformity has given a unique feature also, and that added the value in the product, where it is itself is non-uniform because of the heterozygosity. Greater range of useful traits, because the useful traits are put in the hybrid through the parental lines. So more number of traits can be put in the hybrid, and modern day hybrids or new generation hybrids is like this, where the more number of traits, particularly the resistant traits, are put in the hybrids by the breeding the parental lines accordingly. Then that is very important. Customer can dictate the traits in the hybrids, because we do work in the university or the governmental system where the breeders dictate the trait. But here the company runs with the sale of the hybrids. So until and unless it is purchased by the customer, and if the customer's query is not fulfilled, that hybrid will not be in the market. And naturally the company persons are forced to breed the particular character, to put the particular character in the hybrid itself. Income and employment generation in the rural sector, we have estimated, though the estimation is not very strict one, but we have estimated, and we have got the report from many, particularly the seed section, that about 3 lakh farm families are now dependent or getting their livelihood from the production of the contract hybrid seed production in India. Earning a foreign exchange, I have seen that here we have earned about 600 crores of foreign exchange by selling the hybrid seed that is produced in India. So that is the feature why hybrid breeding is still very, very relevant in the genetic improvement of the crop. Next, please. Wide array of hybrids are available in vegetable crops. And the right hand side, you see the major vegetable crops in terms of value. Number 1 is tomato. Number 2, cabbage. But in cabbage, 100% seeds are imported. We do not produce a single grain of cabbage hybrid seed in India. In tomato, mostly we produce the tomato hybrid seeds. Maybe the parental line from the outside, or we have also bred the parental line here also. Different companies are doing work sometime in collaboration with the public sector also. Chili, again, the import is about 60%. Cauliflower, import 80%, even something more. But watermelon, cucumber, bottle gourd, bitter gourd, ridge gourd, these are all the hybrid seeds that are produced in India, here itself. For which I am talking about that 3 lakh farm families are now earning their bread by producing the hybrid seeds through contract. Carrot, again, the import is 100%. Coriander, again, we import 100% from the outside, particularly from European countries. Next, please. Next, please. Okay. So, targeted characters. When we talk about the modern day hybrids means the hybrids having some specific character, targeted character. In tomato, I'll go through quickly because I'm having time. Okay. Targeted characters, if you see the determinate growth habit, that may be dual purpose, maybe table purpose, maybe processing purpose, but it has got transportability and resistant to particularly three tomato leaf curl virus, early blight, and bacterial wilt. And recently, one hybrid have been released from IIHR with the triple resistance, Arka Rakshak. So that is possible in Indian public sector also. That is a proof in it. Hybrids with extended lifespan, and that is very much suitable for growing in the under polyhouse, or not polyhouse in the tropical condition, maybe polyhouse in the temperate condition where the indeterminate hybrids is suitable. Determinate growth habit, flattish round, high acid fruit, and these are basically the table purpose the tomato. In okra, there are several characters, but all the characters must be with the resistant to yellow vein mosaic virus. Cabbage also, the high temperature tolerant cabbage is very much in the market for last 20 years, and that has replaced the open pollinated cabbage varieties, our old varieties of Golden Acre, Copenhagen Market, and now all are these are the tropical hybrids, cabbage hybrids that are tolerant to high temperature, but should be resistant to black rot and diamond black moth. In Chile also, there are array of hybrids, very pungent to less pungent, but it should be resistant to leaf curl, thrips and mites, and anthracnose in particular. Low pungency with deep range separate market for it. Cauliflower, the early season cauliflower, or the group 1, group 1A, or group 2 cauliflower, this is very high, but that tolerance must be coupled with the retentive colored curd, and it should be resistant to black rot disease. Next, please. Please. In watermelon also, lot of watermelon genetical improvement has been done in terms of hybrids. So initially, there are very large elongated melons was very much preferred, but now the icebox type has come. Sugar baby or icebox type, particularly below 3 kg, with a very attractive red color, with a good transportability and high TSS, and these are now striking the market very, very hard. In cucumber also, the poinsettia type, that is a long, very old variety, but still the consumer preferred that type. In bottle gourd, again it's an example that simply by changing the shape of a bottle gourd, a tremendous value has been added in the hybrid vegetables. That is the cylindrical, small cylindrical fruit, and it first came in the name Shambrat, what I remember. In bitter gourd also, about 25% bitter gourd area is now under hybrid. Mask melon, again, not much, but watermelon has taken a lead over the mask melon. Similarly, of brinjal, naturally, brinjal is a the highly regionally preferred vegetable. In West Bengal also, to see in the northern part and the southern part, the preferences changes. If you see in the Maharashtra and in the Punjab, the preference changes. So it is very difficult to develop the hybrids in the many segments. But the round with purple and white stripe, that is Manjari Gota type, that has a separate market in the Maharashtra, in the Andhra Pradesh, and in the south also. But in eastern part, again, we prefer, the consumer prefer some other type. But if it is resistant to Phomopsis blight or bacterial disease, that has given a very high value to the. Please next. Well, okay, common mechanism that we can skip. But I told that market potential is many, the huge potential in the Indian scenario, but lot to be tapped in this way. Next, please. Next, please. That basically want to discuss a bit about it, because key to the next generation hybrids, that is the parental line. They target all the time the continuous flow of new hybrids with product quality. Now in the hybrid, initially it was only the yield. Then came the resistance to disease. Then came the better adaptability to, that is climatic resilience. Now it should be added with nutritional quality also. It should be nutritionally rich. So if this is the new generation modern hybrids, not only high yielder, but also it is climate resilient, it is tolerant to major insect pests, and it is nutritious also. So if we want to develop that hybrid, the first and foremost step is to develop the parental line according to the character that we want. First of all, widely divergent parental lines. The parental lines must be widely divergent, and now FAO in 2010 also, that they have been discussing and they have been advocating to develop the smart varieties. That means which are climate resilient, because the basic problem that we are facing in whole agriculture is that the yield scenario field is much lesser than what we see in the experimental field. So that means their resilience is much lesser that we expect. So the only solution is that if you broaden the gene base of the parental line by incorporating the traits from the land races, the mutants, crop-wide relatives, to develop the smart parental line, to develop the nutrient-rich and climate-resilient hybrids. So this is the not a same manner. So it should be a different one, and it should be a hybrid of wide genetic base. Second thing, heterotic pool, and the development of the heterotic pool, assembling from the genotype of the divergent as possible. And now the molecular tools are also used to develop the heterotic pools, which is widely divergent, so that the divergent hybrids can also be developed. Built-in resistance. Again, incorporation of the specific resistant gene. I'm giving one example. The tomato leaf curl virus resistant gene is four dominant gene, TY1, TY3, TY4, and TY6. That has been originated from Solanum chilens. And all the tomato hybrids that are resistant to leaf curl virus, either of the 2 or 3, whatever may be, these are incorporated in that. And if you want to put more resistance, then definitely we have to increase the number of the tomato leaf curl resistance gene also separated in different parental lines. So hybrid can contain the dominant genes from both the parents, so that it can increase the resistance. Can bring into the hybrids also by breeding the parental line according to the targeted fashion. Application of the dihaploid technology, double haploid technology, and that has in a modern day concept, the double haploid that is haploid production and subsequent genome doubling, that has become a very effective technology for developing of the homozygous parental line, particularly the in the self-incompatible line, the cytoplasmic male sterile line, and particularly the in the vegetable crops which show very high inbreeding depression. So that has a very unique system and it is being utilized, but that is one of the technology that can be used to develop the modern generation hybrids in this. And next one is the application of the molecular biology. First is marker assisted transfer of the specific gene or QTIL in the parental line, and later on checking the presence of the gene in the hybrids, and the use of new molecular technology in the breeding like gene insertion, gene editing to breed the improved parental line for developing of the unique hybrids, and assessment of the molecular divergence of the parents based on the large number of molecular markers. And basically we started determining the divergence of the parental line based on the multivariate analysis and with a specific character. Now these tools can be used very specifically for assessing the divergence between the parental line and assessments of the and maintenance of the genetic purity of the hybrid seeds. So these are the new areas, not new, but it has started utilizing by different companies and the public sector, the universities also holds the key for the development of the new generation hybrids. Next, please. Next, please. Okay, I'm citing some of the example on the mutant which we are working. In tomato, I'm giving one example of tomato. We are immensely producing tomato, but till today we are importing the tomato puree from different countries, particularly because our lycopene content of our tomato is much lesser than what is actually needed to produce a very good ketchup or very good other tomato product. So these, how to do it? One aspect is left there to induce the mutant, which are lycopene enhancing mutant in the parental line. If you see the dark green DG or DGHP2, what is it? It is allelic. HP1 and old gold crimson, these are the spontaneous mutant, and the mutant DG1. We have developed this mutant from a project of Baba Atomic Research Center. We are still working with that, and that is a photoresponsive mutant, and that gives a very high lycopene content. And if you see, I've given the chart. We have been working for last 10 years. The average number of hybrids, we have taken 38 hybrids in different times. If you see, the average lycopene content is 3.83. It is very low, and for this reason we import the tomato puree, huge quantity of tomato puree from outside. And last day also in the in a lecture, the DG also mentioned, DDG also said that in other last year, then we have to develop a tomato hybrid which should be not only yielder, not only resistant to insect, but also it should be qualitatively good, so that we can use that hybrid in the processing purpose enormously. If you see how much, please. Hello, how much time do I have? Hello, sir.
You can.
Okay. Earlier slide, please. Earlier. Okay. Now you see that 3.83 the average lycopene content, and if you see in HP1 high pigment 1 gene, if you incorporate, that is the lycopene content may be doubled. In OGC, in DG, it is also 6.22. So that is a good option is left to enhance the lycopene content in the hybrid through the enhancing the lycopene content in the parental line. Next, please. Next, please. Okay, this is another way of enhancing the nutrient content. We have been also working on, we have also developed a new tomato, that is purple tomato. Again, the Department of Science and Technology, Government of India help us a lot in giving a project in a long way. Again, we have integrated 2 genes together. One is the anthocyanin gene, which is present in chromosome 10, and the DG, which is present in chromosome 1. And both are having the morphological marker. And now we have also developed a molecular marker also to identify the presence of the 2 gene in the. So by conventional breeding program, we have developed purple tomato. And if you see in purple tomato, the lycopene content is 6.13 milligram per 100 gram. Anthocyanin content is 20.73 milligram. And normally in tomato, fruit do not express anthocyanin in its pericarp, because anthocyanin, particularly chalcone synthase gene, has been silenced during the evolution of the tomato. So in the all Solanaceae, all members of the Solanaceae family, they express anthocyanin in their fruit. Tomato express anthocyanin in his other plant part, in his stem, in his petiole, but not in fruit. If you see in the right hand side, two years back, one commercial hybrid named Eclipse Ruby that has been developed and being marketed in the Europe, they have developed a parental line which is having the anthocyanin fruit gene, and now they have added the value in it, and a new hybrid have been developed. So the concept came earlier, and that can be done. The field is open to develop a new generation hybrid, because I'm talking about in this way. We have started with yield, then the disease resistance, then adverse climatic condition, then now with the nutrient quality. So these are all amalgamated in the new generation hybrid, and this we can do it if we manipulate the genes from the mutants. Next, please. Okay, we have been working with wild relatives also, because relatives, particularly Pimpinellifolium and Serraciforme, are also working with Peruvianum also for the other purpose. But the Pimpinellifolium and Lycopersicum who have been working for long for the development of the good segregate with a high quality, particularly in the TSS and lycopene content. And I've presented you a graph with a 5 segregating generation. If you see there are likelihood of getting the recombinant line with the wild means Serraciforme for the TSS content. So if we again want to develop a high quality parental line, we can also use the also for development of the parental line. And we have seen that, and it has been seen that in different cases, in different parental lines can be developed with different wild relatives also. So that is another arena that we can exercise. Next, please. Next, please. Okay, just I'm going to finish in that way. Now we started with biodiversity. We advocate biodiversity all the time. Then we landed with a monopoly crop or monopoly aspect, that is hybrid. But again, we told that the full potential of the hybrid has hardly 35% of the potential has been tapped, but lot remain untapped. And how to improve it? Not only so, first of all, the hybrid location specific and climate resilient hybrids, that is the need of the day. A successful hybrid should be nutritionally rich and show adequate tolerance to targeted biotic and abiotic spaces. And for this reason, the hybrid seed deliveries of different vegetable crops must be adequate and timely. And bridging the awareness gap among the farmer regarding the better management of the crop. So hybrid, if it is not better managed, definitely it will not give the full potential. And an idea we nurture the idea in that only if you develop a hybrid or grow a hybrid, it will give a very high yield. So it is not in that way. It should be managed properly. Otherwise, so the hybrid that I'll show later on, the hybrids won't give its full potential. Next, please. Next, please. And this is the last one.
Confusion. It's not conclusion, it is confusion.
Yes, it is a confusion.
Yeah, sir, clear the confusion. Clear it.
And concern. Confusion is that in organic agriculture, it is ecologically oriented production system. It is confusing why they do not advocate using the hybrids. That is a confusion in my mind.
Oh,
Because it is not a ecologically different system. So the organic system can easily adopt the hybrid technology or the material that is a hybrid cultivar. Again, it is a confusion that it is a rampant confusion. All the hybrids are less nutritious than the open pollinated crop. Maybe some of the open pollinated crops are more tastier, maybe more healthier, I also told, but it is not all the cases the hybrids are less nutritious, so it can fetch lesser price. That is a confusing thing. Okay, that it is a level of awareness, not only in the management system, but also in that system that is required. Still, it is required. Concern. Again, that I will end with the dovetailing the two aspects. One is the hybrid may be uniformly resistant to many important diseases and pests. It is so, but it may be uniformly susceptible to new disease and pests. That has happened earlier in the USA. The maize carrying the T cytoplasm, it is very, very susceptible to corn leaf blight, and that system need to be changed, and that has been changed. Second concern, and why the hybrid is again only 35%, that is the poor performance in the risky environment. That is, it is not climatically resilient. So high temperature, drought, excess rainfall, and a flood, that is a common phenomenon now today, earlier also. In that cases, the farmer rely more on their saved seed. That is open pollinated cultivar, they rely more on them than the hybrid. Because again, the modern day hybrid or new generation hybrid should be climate resilient. Again, the wide adoption of hybrids, again a concern, it threatens the agrobiodiversity, because in one way we are talking about the conservation of the biodiversity, but if you go to the monoculture, if you adopt the hybrid more, naturally it may threaten the biodiversity, and it may create a dependence of the farming community to the big companies. That is the social problem, but all the science cannot be away from the social aspect. The last one, may I have the last? This is the conclusion. Let us join hand to conserve the biodiversity of vegetable crops. for sustainable diet and nutrition. Thank you very much, sir. Thank you very much for your patient hearing.
Thank you, Hajra Saab. You have to answer few questions. Questions, please.
Please.
Somebody can read the questions, please. Hello.
Please.
Yes.
Hello. Hello.
Hello, sir.
Organizers.
Hello, sir.
Sangeeta ji.
Yeah, am I heard, sir? Am
Oh,
I
yes.
audible?
Yes, I'm hearing you.
So there is a question. Climate change and the present pandemic situation has put the world in partial trauma. Most of the time, our approach for reaching newer heights has been based on exploitation of available genetic resources and socio-economic factors as baseline. Can we innovate measures like faster adaptation of weedy plants as new crop species, help us to tide over the crisis and be designated as new generation crops?
Okay, it is a very relevant questions, and I'll answer it because I have gathered many information from my students who are working as a breeder in the different hybrid seed company. I am answering from their version. So according to their version, in the pandemic situation, there is a tremendous potential that they have seen for the sale of very good quality hybrids, because the area has been increased in vegetable crops, particularly some of the person who left vegetable farming or agriculture for as a migrant worker, or they have settled from the foreign countries here. So they have started agriculture in a big way. And in these cases, the very good hybrids, particularly the resilient hybrids, that has got a good promise. That is one sort of answer. Second thing is that we advocate, we are now advocating the farmers also in a different awareness program in our university and in our arena also. You conserve your own material now. You can use your hybrids, you can use a very good varieties also, but don't lose your genetic material which you have developed or you have got from generation to generation. That is the new strategy. I think it should be.
Good. Any other question?
Sir, there is one more query. Are there any hybrids in yard-long bean?
Yard-long bean. Any hybrid?
No. Because it is, again, then why it is not? Because in yard-long bean or any cowpea, it is the Vigna unguiculata subspecies and the sesquipedalis. One pollination may result only 6 to 7 seed. Vis-a-vis, one pollination may result more than 250 seeds in tomato. And that is the reason why in peas, why in yard-long bean, hybrid will not be available, because it will be too costly. Again, in the pollination system also, we cannot manipulate the flower because it is not a clistogamous flower, but it is a closed flower. You cannot cross-pollinate it outside. This is the reason.
So you can generalize all the legumes?
Yes, same thing. Because some work is going on in ICRISAT in chickpea, because again in chickpea in the male sterility system, but again the open pollination is very, very hindered. In tomato we have seen hardly open pollination is very, very low percentage of open pollination. And if the pollination mechanisms is not amalgamated with the open pollination, then we cannot reduce the cost of the hybrid seed production. There is no use of it.
Okay. Next question.
So there are no more questions from you.
No more question. Very good. Yes, at last. So I have to profusely thank Hajra sir for excellent presentation.
Thank you very much.
particularly on the new hybrids and conservation of biodiversity. We have lot many vegetables, though they are being used but not popularized.
Yes, sir. Yes.
And certain germplasm is not yet touched even, but they have got a potential to be a source of a good nutrition or to be a palatable vegetables. That is there. Very good talk, sir. So thank you so much for this. The number of things you have highlighted. For some time I disappeared because of the breakdown at my place. Light was not there. Anyway, that is the part of Indian scenario. We have to live with it. So I think now the time to summarize all that. We had a fantastic day
Thank you
long.
very much, sir. Thank you very much.
Okay. So permit me to summarize. Organizers, can I summarize?
Sure, sir. Please.
Yes, sir, please proceed.
See, we had, I think, day-long session starting from 11:30 or so. By now, it's going to be 4 o'clock. Good. And we had only 4 talks into that, but all the 4 talks were very illuminating, and lot many things have come up in that. As you see, Dr. Balraj presentation, protected cultivation of vegetables in humid tropics. He tried to tell you what all we should do under humid tropic relation to the structure for growing the vegetable there. All sort of a permutation combinations are there, but what I want to add here, whether it is a pollination or something else, entry of the insects or humidity reduction, my personal feeling, I wish I am not wrong, is that we have to experiment upon, because we have got the niche of the climates, microclimates. Kerala as such may have a particular climate for which the Kerala Agriculture University can give the better solution than asking the expert, whatever the level of expertise they are working somewhere else. You can take a clue from that technology, but you have to modify it to suit the local condition. These days, local word is very, I think, becoming important. So here also in protected cultivation, the local way of doing the protected cultivation, that will give the good return to the farmers. Otherwise, farmer at his field has to experiment and find out the ways and means. So this was about him, and he gave a lot many options, even the value addition, dehydration of crops under polyhouses, that is value addition, a lot many things he covered. Then the second was on 2 aspects by ADR Kuttiji. Very informative, and he tried to collect the literature world over. He gave the world scenario on vegetable grafting. All sophisticated machinery, automation, and what not, he has not brought that artificial intelligence to that, but he must be built in on that. So he has shown that highest level of vegetable grafting. But for our Indian condition or the Kerala condition, we have to depend on manual one, which he has shown different ways of grafting. And I tell you, this vegetable grafting is getting popular. You may be knowing that VNR seeds in Chhattisgarh is multiplying vegetable grafting or supplying vegetable grafting in several, I don't know what number it is, and he claims that he is exporting also. So it has got potential to that extent in different vegetable, and he started with Solanum torvum as a root stock for tomato, etc. Now he is talking about so many things, all that. But what I want to emphasize, that we should breed for rootstock. And I think, I wish I'm not wrong, that we have to switch on to tissue culture of that rootstock for fast multiplication and the sign multiplication, and see that perfect the condition, this grafting with automation, at least partial automation, so that the farmers can get good crop, and that our friends who object to even hybrids, which Hajra Saab mentioned, the organic guys, perhaps they will have no objection to the vegetable grafts. So a lot of potential for vegetable grafting, what I see, lot of research is required on that. Then another thing, he expect the future vegetable production. Why I say future vegetable production, which is soil-less vegetable cultivation, whether you agree or not, it is going to come up because of its lot many positive points. Let me see about the nursery. For vegetable production, major thing is to have the healthy nursery, and you can't get the healthiest nursery other than the soil-less medium. And moreover, the transportation of the nursery and other thing, number of things, you are all expert in that, you know it better. Protex production and production of the nursery under protected condition or controlled environment and all that. The importance can't be overemphasized that. Likewise, places where, hello, is there any problem?
No, sir. You may proceed, sir.
No, okay. And then we are heading toward that urbanization, and in urbanization, producing the vegetable, eatables or food nearer to the place of living. Nothing can be better than that soil-less farming, whether you have got a space or not, whatever living space is there, the technology is there that you can produce with that. Only thing the resource, that what I consider the light. See, we face the problem of breakdown during this one. Such things won't help, but we have to have the foolproof inputs in that. You can have the vegetable anywhere and fresh vegetable, even that microgreens, what we call, somebody listed there, microgreens. A friend of mine was telling the other day when we were having a webinar that you can have the microgreen on the dining table itself and go on enjoying if they are fully hygienic one, if they are multiplied under the hygienic environment. That good. So these things are going to come up. Very important one, soil-less vegetable cultivation. And I have served in the defense, and we work for the soldiers, the man in uniform, and big problem on border areas, high altitude, other places to give them the fresh, particularly the vegetable. But these microgreen and soil-less vegetable cultivation, it is possible wherever they live. And I don't hesitate to say that you vegetable scientists should work on these, because tomorrow if you have to land on moon and I have to start, your generation start living there, they will require food. How will you produce the food without the soil? So have the technology of soil-less production of vegetable, which is possible, and it has been amply proved, and it is being practiced. So that much is the importance of that. Thank you, Dr. Narayanakutty, for giving the elaborate presentation on this. And I think in the recommendation, it should be highlighted soil-less vegetable cultivation and grafting sufficiently in that one. The next talk was on the recent development in crop management of important vegetable under polyhouse and rail centers. What a presentation by Dr. Shankar Haber. Great experience the scientist has, and he has given the practical the problem with everything. Technology is there, but the problem with that beautifully he has presented that. And ultimately, what I could understand with that, you have to standardize. The technologies are there, and number of technologies are there for a particular aspect, but you have to standardize for your own condition. Where do you want, where you want to use it? And somewhere he made a mention, before undertaking anything, please see where you want to send the produce. So market first. I also advocate that before starting the protected cultivation or any venture, you must see the market first, then only think of, not that first produce and then look for the market. The failure will be there in such a case. So better to see the market and accordingly you go for that. But if you are going on a small scale, go ahead for home consumption, etc. One can have these technologies adapted. There is no problem in that. The last one, which is must be fresh in your memory, just now Dr. Hajra spoke about the future vegetables and new generation hybrids. The future vegetables, he told there are a number of unexploited vegetable crops which have got the better nutrition, better potential, climate resilience, and a number of good things. And it's a vast one. He told that only 25 species we are able to exploit. And in that also in the morning, DDG said that we are harping upon only 7 or 8 vegetable. So right, our base is very narrow, so it has to widen. And because of the so many things are happening, climate change, this and that. So it is very important. His talk is very important. And then he went to the extent of that a new generation hybrid, what all the new generation hybrids should have. And the confusion which he talked about, I'm with him, 100% with him, that the organic people, why there should be objection to them for the hybrid seed or even genetically modified seed. Seed is a seed. Where is the organic or inorganic aspect into it? The everything, even your organic thing, we all know it very well. Whatever nutrition the plant is taking, it is taking in ionic form only now. And moreover, this organic, I have got a, though I also like organic, you also like organics, good. But as far as the science goes, in organic, when the movement started, it started for improving the soil health. It is related with improving the soil health. The soil health has become secondary, human health become primary. Organic system was promoted because the soil health was getting deteriorated because of the abuse of use of fertilizers, weedicides, and whatnot. Number of things are there. So to overcome that abuse, the movement started how to improve the soil health. But that soil people have forgotten. They have gone to the human health straight away. I need organically grown, whether it has given the produce only 1/5 of what we get in other system, but organic one. No doubt, organic thing tastes better. And that taste also we have to define. Perhaps the taste also can be of the organic one, provided the science penetrate to that extent. After all, it is a chemical thing. Taste also is a chemical one. Everything is a chemical in that. Only thing the science should be understood properly, how the taste is created, however complex it is. Once it is sold, I think there won't be any problem, those who understand the thing. I give you one example of my own. See, I don't know, I'm mad after this hydroponic. And this hydroponic thing I have got in my courtyard. And I don't have the control condition, etc. I'm growing in open, and that too is seasonal crops I do grow there. Sorry, I'm taking your time in that, but this is a worth sharing one. This summer, I had the mint podina, what we call that. I compared the podina grown in hydroponic, much more flavorous, much more tasty, everything much more than the mint grown in the ground or what is available in the market. So one has to scientifically find out and prove that. Perhaps I am supplying the balanced nutrient to them from the soil. It's not necessary that it has got the balanced micronutrient and the macronutrient required by a particular crop or variety. But in hydroponic, you can manipulate it. You can do it provided you have got the gadgets to know that what plant wants and what we should give. So anyway, science is important, and particularly the basic science. We should understand the basics of that, then only the applied science will come. So in that respect, I think all the four speakers have done a marvelous job. I'm thankful to all of them. On behalf of organizers and on my own behalf, I again thank them profusely, and I thank the organizers to tolerate me for such a long time and providing the opportunity to be with you. I have learned a lot. Thank you so much.
Yes, sir. Sangeeta, we will conclude today's session.
With this, we come to the end of today's program. We would like to extend our heartfelt gratitude to the chairman of this session, Padma Shri Dr. Chandra Singh Ji, for sparing his valuable time and sharing his valuable experience with us. We would also thank all speakers of the day for their informative and valuable talks. Tomorrow, the session begins at 9:30 a.m. The link for the panelists and participants has been made. Kindly log in well in advance. Thank you one and all for your kind cooperation and valuable participation. Wishing you all a good day. Thank you.
Thank you.